what we have been doing on High Speed 1, and which led us to see the ballast cleaning machine for switch and crossing in Austria working earlier last year.
Get rid of it. Try the arrow.
Yeah.
Oh. I'll go here.
Oh, there we are.
Right, sorry about that.
Yeah, just that pictures of the two machines we have been deploying over the last couple of years on High Speed 1, which will lead us to our topic. As a bit of an introduction, what we've been operating on the network down in Kent, then some facts and details on our tamping and ballast regulating, and after that I will hand over to Mark and Richard to present the machine currently working in Austria, and we will all be available for questions at the end. Most of you and those online will know what High Speed 1 is all about. It's a 109-kilometer railway built to European design gauge, connecting London with the Channel Tunnel. And the only railway in the UK running at 300 kilometers per hour for the international traffic and 230 for the domestic services. And yeah, now operating for 22 years, and the full route since 2007. Was owned by HS1, but as a lot in the UK has been sold off to somebody else who are now managing it. And Network Rail High Speed is the business unit or the contractor that maintains and operates the infrastructure and 3 of the stations on the line. They have a plant fleet and modules they use for general maintenance and overhead line checks, but do not own or operate any specialist yellow plant. And that's where we basically came in now 13, 14 years ago, when we were successful in the 2011 tender to supply, maintain, and operate high-speed tampers and regulators. As mentioned, in 2011, we started the project and were lucky to get one of our Austrian-based Plaza 0932 dynamic tampers, which is a double bank tamper, so it tamps 2 sleepers at a time, and is fitted with dynamic track stabilizer, which wasn't used from the very start, but HS1 was very keen to explore these options. The machine can tamp S&C as well as plain line, and under a good operator can manage up to 1100 meters an hour of plain line track, which quite often on HS1 is achieved because it is clearly one of the most modern pieces of track you can find in the UK, and you have enough space there for the machines that we bring on as well. Initially, the tamper was teamed up with a smaller SSP 110 ballast regulator, which is an older design 2-axle, which was never a favorite with the guys down there. So a couple of years later, we were able to get our more modern BDS system, which is basically, if any of you have seen our AFM that is operating on the UK network, ballast regulator with ballast plow and a massive hopper unit carrying up to 25 tons of ballast, and which can distribute the ballast it collects in other places via various ballast chutes and ballast trousers. So in areas with excess ballast, it just picks it up and drops it where it's required. Working with HS1, we started to use the DTS on all the plain line tamping maintenance shifts, and they were happy with the results. So we continued a year later to utilize them on all S&C tamping shifts. And it has been quite a success so far. So they never went away from it again. And up to date, we have been carrying out, I think it was 13 annual campaigns of design tamping. So there's no measurement and computation tamping done on high speed with these machines. And initially, there was a bit of catch up to do. So the first couple of campaigns, we tamped up to 50 kilometers in 5 or 6 weeks of the plain line track. And basically every Saturday night and sometimes Sunday night, there was a crossover to be tamped. So they had a bit of backlog on all the point ends and turnouts into the sidings along the network. And typically we were deployed 6 shifts a week, so only the Friday night was off for the guys. And current plan is the machines will arrive around the 4th or 5th of March this year to carry out another 5-week campaign. And we also supply a smaller tamper, 08 compact, which is fitted with the Sprinter software, which is used for shortwave tamping work. So they usually treat 10 to 15 meters or just a couple of sleepers across the network. And these machines can be deployed pretty quickly whenever it is required on HS1. But over the last couple of years, they usually aimed that in the second part of the year away from the big machine campaign, just to catch up on some of the track faults that have been developing. And can be quite effective along the track. I think the record was about 16 individual track faults along the line in one midweek shift. Here you see the tamper with the proud crew in single well depot. And another picture of the third arm going out, tamping S&C on a night shift. You can see the workings of the BDS system with the center and lateral plows and the brush system. And up at the top, you can see it in daylight. And the bottom, middle, and right, this is the compact tamper, which is fitted with the Sprinter system. And in trials in Dollins Moor on the left-hand side and stabled down there. And here we see it working out on the network, and just a screenshot of the ALC with the Sprinter program running. And being operational for 22 years plus, our operators during the campaigns over the last years obviously noticed that there are certain sections of the track which I tamp every year, every campaign. So some of the ballast is clearly spent and requires works which we've been discussing with the HS1 guys, who then visited the machine in Austria to check if it will be feasible for them to deploy on the network. So this leads us to that chapter that there will be ballast cleaning happening on HS1 in the near future. I'll pass over to Mark Simmons.
You need your slide. Okay. Just bear with us while we change slides. but this one seems to be working now. So you should be able to.
I should be able to click through.
Just click through. Right. The only thing you've got to be careful of is keeping just the side
Of the light.
Yeah.
Right, and somewhere within the camera. Okay, perfect. Yeah, good evening. I've said hello to a few that I already know, but just to introduce myself, see I've got the location incorrect, sorry about that, but we'll update that. My name is Mark Simmons. I'm the Managing Director at Plaster UK. We are the agents for Plaster and Tyra in the UK and Ireland. Good that at a joint meeting of the PWI and the IMechE, I happen to be a member of the PWI and the IMechE, so that works out quite nicely. So it's changed on here, but it hasn't changed up there. And it hasn't changed on there either. Okay, go back to this.
Just gotta go. That's tricky then, isn't it?
Yeah, that's changed. Arrow keys, it looks like.
Okay, if you could.
We'll do that. No. Okay, I'll have to do them both. So no, now that's working. Okay, now that what I haven't got is a visual in front of me that changes. Right, if you don't mind, yes, I can. I'll use that one. That worked perfectly. So apologies for that. Very broad agenda, roughly what I'm going to talk about. The machine that Michael and others went to see in Austria, and the guys from HS1, and we call the URM 700. It stands for the German Universal Reinigungsmaschine, the universal cleaning machine, and it's version 2. We'll get on to what changed roughly as we move along briefly. How it works. A very short video of it actually doing some cleaning, some detail on some of the shifts that have been completed in Austria so far, and then a brief look at what could be possible in the UK beyond HS1, fitting into the much smaller profile gauge that we have available, what you might need to support it, and how it could work if we were using it on other parts of the UK network. That's the machine we're talking about. We'll go into it in a bit more detail. I think on the next slide, I actually have a layout drawing showing it, but sometimes it's quite useful just to see a big overhead view before we get into the nuts and bolts and a bit more of the detail. You can, I don't think I have a pointer, but you could sort of see where you see one of the electrification masts standing up there. There's the front trough for the shoulder cleaning that cuts the trough into the shoulder first, and then you see a second one coming up behind that picks up the ballast from the sword.
So there is a pointer, the red at the front.
Yes, but I'm not sure if everybody online would. I suppose I could do it like that.
Yeah, they might just see it.
Oh, there. So there we go. You start there. So there you can see the old ballast is still in place. Here you can see we've cut a trench. There is a sword underneath here that's cutting out the ballast, and that gets picked up from over here. There you see the spoiled ballast heading forward. The back here would be some new ballast being distributed, bringing in. There is sieve for cleaning and returning the ballast back in. We should see it in a lot more detail. Brief details of it. Here you can see it again with, sorry, there you can see it packed up for transit, and here you can see it opened out, facing the opposite direction for working mode. You'll notice that the height over the top of the rail is well over 4.5 meters, so you certainly wouldn't get that inside most of the UK network. But as Michael was showing, some of their very large show 932 machines operating on HS1, it fits into European gauge, so it would be perfectly feasible to bring this over in the same way and operate this machine on HS1. Individually, this unit, the switch and crossing cleaner itself is 67, just a bit more than that meters long. in the very initial picture when we started off, you see it coupled with a rake of MFS wagons. Again, those are continental size wagons, MFS 120s. The ones we operate here are a bit smaller than MFS 40s. Gives you some kind of an idea of the volume difference of what you could manage. What might be a bit more awkward would be to operate those on HS1, not because they won't fit, but you need to be able to take the stone that you've taken out, spoil, and dispose of it somewhere, and they obviously can't travel across the rest of the UK network to get there. So you'd need logistically either to arrange a way to handle that spoil out of HS1 without the wagons moving out, or perhaps to operate it with UK-sized MFSs for the rest of the network. So as I started earlier, this slide shows you the beginning of the operation. So the shoulder cutter chain excavates the first portion of the shoulder. That shoulder ballast that's been excavated gets screened and brought back in if it's suitable to be returned behind. That element of the ballast that doesn't make it, either too small or too large, gets spoiled into the wagons that are, in this case, on the front of the machine. Make sure it is still showing up there. Okay, then into that space, we deploy the cutter, which is a sword. This version of it is a lot smaller than the original. I said this is the 700-2. I can't quite remember, but it may have been as long back as 2013 or a bit earlier. We had this original machine was the Urim 700, was operating in Austria. Actually, a crew came out from Network Rail to observe it, and they sent us quite a useful report afterwards of, if you were to deploy this in the UK, certain things should be altered to make it more suitable for our infrastructure and the way we operate, one of which was to shorten the sword. And in fact, this sword is now a shortened version compared to that original one. But the sword starts out laying into the trough that's just been cut in the shoulder, and then it cuts its way in underneath the track or the crossing, and then depending on how far it can go, up to sort of 90 degrees, and then starts cutting through, and depending on the obstacles you might reach, it can then move out the way. So it gives you the opportunity to position itself underneath and make sure that you can avoid obstacles. In this case, you can see the space that you can fit it into. Again, in the UK, some of that might even be a little bit smaller if you're on Network Rail. I think on HS2, HS1, sorry, I'm not sure there's that many where you have such narrow space, but it shows the options that are available. There you can see then that sword cutting in underneath, starting to swing in. It scrapes the ballast out from underneath, brings it back to the shoulder area, and then the second scraper conveyor system picks up that excavated ballast, transfers it up and brings it back to that screening unit to be screened and cleaned. And then either the cleaned ballast is returned back into the track, and the ballast that doesn't meet is sent forward again as spoil. And obviously some of it, if you've taken out the ballast, you've sent forward that ballast that isn't suitable again to be spoiled. We need to replace it with new ballast. So in this case, MFSs behind bring in new ballast, and then that ballast can be brought in and distributed over to replace what you've been missing. It's inserted via two slewable conveyors, so that allows you to position that ballast exactly where you need it in the forefoot or onto the shoulders where you've obviously cut it out. Right. Now, I'm not sure how to play this video from here. Can I get it?
Is it in the, embedded in the?
There's a little button at the bottom of the video that I need to click to play it. I can't see the mouse, sorry, let's get back this way.
Which slide are we on?
Yeah, it's this one. It's that slide. No, it's that slide over there. It's just underneath. It's just hovering there, just underneath the picture. There.
Oh, there.
It's not.
No.
It's playing on here, but it's not playing on the screen. That's what I was worried about, how to make it play on the screen.
That was something there. Right.
Now you got the mouse to work on this screen earlier, and I couldn't quite figure out how to do that.
We might have to just play that again in a second. Let's go back. See if we can get this. Oh, I've lost it completely now.
The video is not long, but it would be really quite helpful to see it because it's reasonably difficult to explain it just using my hands exactly what's going on, and when you can see it directly, it does make it a lot clearer. So assist a little bit just to try to get it to work. Oh. Something happened there, definitely. You were on the right screen.
I've lost it. Oh, what's going on here?
Yeah, it's back up.
Yeah, but I can't.
Comes to this screen, but I just can't see the mouse. Probably my only major issue is I can see where it was.
Oh, for goodness sake. Oh, I've lost it. Sorry.
Briefly share the other one.
Share this window. Share. It's not sharing it. I can't get
the mouse to appear. Okay. It doesn't. Oh, there we are. That's what I've been looking for. We seem to be missing the sound, but I think we'll all do perfectly fine.
Probably I can.
I think it's probably we're probably getting feedback. First point to note was the passing train. One of the important things is that it's an inline ballast cleaning system, so it is possible to obviously maintaining the correct distances, but it is possible to operate with a train passing on neighbouring track. So you can see the ballast passing up the shoulder conveyor, going into passing the screening unit. Here's the sword beginning and starting to cut in underneath. And the point with this is exactly as it said, you can get an infinite cutting width up to the width of the sword, depending on the angle that you've got it set up. The material is then picked up, I say, by the second conveyor. One of the important changes we made were that the track lifting and holding devices is mentioned there. So one of the points mentioned was to make sure that you have as much of the crossing supported as possible, so that two lift units, and the lift units are movables, because obviously there's areas where they can't grip and hold, and so you can make sure you can switch between the two. There's the slewing conveyor bringing in ballasting at the rear. So you end up with only, I think we said, Michael, about 5 sleepers or so that are not supported by ballast between the cutting and returning ballast in behind them. There's the vibrating screening units. I think there will be a later picture that shows you the screens, but ultimately it separates our ballast so that it's only the right size and returns that ballast back again. And then you can see it moving forward to the hoppers. Right.
So now we're going to be able to get back onto the next slide.
Yes. Right. What was the point of setting all that up in the very beginning? I say that the first time they created it, the aim was to be able to clean through switches and crossings in a more continuous way, to be able to reduce the setup time and possession times, not needing to take the crossing out to dig the ballast out and then put it back in place, being able to operate with the adjacent line open, which is obviously a lot more cost effective than if you have to close the neighboring track if possible, and ultimately come up with a fast, safe, high quality and efficient way of cleaning switch and crossing ballast underneath the switches and crossings. So some of those things that were changed from the original 700 to the 700-2, what they actually did was took the original machine, cut it up and reassembled it back again. They created that extra shoulder cutter in the front that creates the shoulder, the original version. You had to cut the shoulder out, set back, put the sword in place, and then go forward. And the idea was to make it a lot more efficient by having them operate simultaneously, picking up the ballast with the second shoulder cutter. I spoke earlier about being able to hold the crossing, and you saw briefly in the video that you could also move the clamping units backwards and forwards so that you could really create an opportunity to manipulate your hold on the crossing and make sure you never have to release it, even though there's inevitably places where one or the other of the units can't actually hold it up. Also reduce the length of that sword, be able to keep it much more rigid, get a very clean cut underneath while still being able to reach all areas of the crossing as you're going through it, but still have the versatility to be able to manage any obstructions that you come up with. We didn't see it in the video, but there is also a water tank integrated for being able to do a bit of dust suppression. I think we all know at the moment ballast dust is quite a topic here, and also coming up in Europe, particularly with trying to manage the silica dust inside it. So anything you can do to damp down ballast, and especially in situations, both the new ballast when you bring it in, we noticed that with the high output ballast cleaners for that they're operated on network rail. When you bring the new ballast in fresh from the quarry, even just sitting inside the MFS units come into sight, as it runs along the track and gets shaken along, all the dust that's just sitting around it comes out in great clouds as it travels. And once you get there, you've got this coating of dust that sort of spreads up around the worksite, and the people that are operating it end up potentially breathing that in. If you can damp that dust down, but certainly makes a big difference. We fitted in West Ealing at Plaza UK a number of the MFSs for Network Rail with water tanks inside the silo. We allowed the conveyor to continue moving the stone underneath, but fitted big water tanks in the silos and created a system where you could suppress that dust. Had an absolutely enormous effect on days when you really do have a lot of dust coming up from it, and obviously also from the dust, the ballast that you're cutting out from underneath. So you're certainly passing it through sieve. The whole point is to shake it, moves all that dust off. So as Michael said, the HS1 team, along with Switalski and some of the people from Plaza UK, went out to Austria to see the ballast clean operated, the switch and crossing cleaner. It was operated, in fact, it's owned and operated by Franz Plaza. They're Plaza and Teurer operating company in Austria. They have truck maintenance contracts in Austria, along with the other much bigger providers. Generally, the contracting companies like Switalski, who have maintenance contracts in Austria, but they traditionally, as part of those contracts, they test out the newest series of machines. They often get the very first version of it, or the version 0, operate it, work it in real life, discover what could be done better, and that leads to improvements so that the first customer machines have already been tested in true operation and under real contractual conditions. So France Plaza were operating the machine that the HS1 staff went out to see. Yeah, as it says on the bottom, it's probably one of the things we say quite often for the high output ballast cleaning system here. The logistics around a cleaner like this and the high output ballast cleaners in the UK are one of the most complex things to manage. You're talking about a fairly big deployment, number of people, systems, machines, the ballast, dealing with the spoiled ballast. And one of the more cost-efficient ways of utilizing it is campaign working, moving that entire circuit from one place to another and then back again. Costs a huge amount, and your unit cost for cleaning goes up enormously. If you can manage to do them in campaign shifts, you really get a lot more done for ultimately a cheaper price and a more efficient system. And that's the way they operate it. Changed on the okay. Has it changed online? Yeah, okay, there we go. So here we've got just a few images that I got from my colleagues in Austria of shifts that they have actually completed with the second generation of the machine, and rough timings for how long it took them to do the job. The top image is at Kumpendorf. I can't remember where you guys were. That's where you went to see the machine operating. They did 3 separate, almost campaigns, not quite the right word, 3 separate shifts there. Mixed knits as well. Up and there.
I have no idea. Oh,
okay.
Let's get the blank
right, okay.
button on there.
Right, all of these were Schwanenstadt. Big campaign there, multiple shifts and to cover all the various switches and crossings and in different locations. There I only have 4 of the images for you. So you work our way through, and last one they've done most recently in November at Karlsdorf. Right, just once again, so that you've got a view of the machine itself, having spoken about a bit before. Again, I thought a good time just to stop again and have the overhead view, get a basic picture of what it looks like now and its current state and how it feels. Before we talk a little bit, from my point of view, if we moved away from HS1 as a singular network, using that machine as a possibility, would it be possible to do similar inline switch and crossing ballast cleaning in the rest of the UK network? Back in 2013, I did a study with somebody from the Eastern region to see whether it would be possible. And this is the design that Plaster and Tora came up with in 2013 as a concept for how it could be done. Get into the individual detail of machines that you see there now, and then I'll point out the particular elements of it. So yeah, we've got, I'll speak about them each individually. A power car with the shoulder cleaner, an undercutter with the sword that we saw, ballast distribution wagon, and worked out for this particular arrangement, although you perfectly well could use the standard MFSs, need some adjustment to how we've set this up, but a new version of the MFS wagons that we thought would operate with this quite nicely. What you are looking at, and this concept is a 270 cubic meter per hour ballast cleaning system, which gives you, depends obviously entirely on how wide you cut it and how deep you cut it, but we're talking about 100 to about 150 linear meters per hour potential cutting. So we mentioned before, adjustable width, adjustable depth as well, up to a certain point. Key to be able to return ballast directly behind the cutter bar, so that you've got as little of the track or the crossing unsupported as possible. Integrated dynamic stabilization, and efficient distribution of the ballast. Yep, switch over. Right, here we're looking at the front end. This is the power car and shoulder cleaning machine. It's not intended as a power car for this to self-propel on the network. Still need to be hauled by a locomotive, and particularly when you consider the MFSs being pulled behind with all the stone inside them, much better off as local hauled. But the power car needs to give it power for pulling the vehicle through while it's doing the cleaning. Needs a huge effort to drive against the ballast and for the chain to dig the stone out from underneath. That also needs a lot of weight to provide the friction down onto the track itself so that it can create that traction as it's cleaning. So in that front cab, though, we imagine providing messing facilities for the staff. In this version, we had a plow and a shoulder cutter, and a spoil conveyor coming up back. Probably should say it here because if you notice, the system is called a ballast cleaner. In fact, in this concept that we drew up in 2013 with the Eastern region, the discussion was heavily around, well, they wanted to minimize the cost of the machine where they could, but it was also heavily around for many years already. Back in 2013, crossings hadn't had the ballast cleaned up from underneath them, and so the thinking was that actually the amount of ballast that would get returned was going to be quite small, and so for a first stage we would do this as a complete undercutter, and you would just replace entirely the ballast. The concept did have a drawing that included a later edition where you could bring in a screening car as an extra. I spent ages before this presentation searching my entire email archive and all the drawings that I have on the system to find that screening car. And eventually, late last week, I think, I realized that I saw that concept in Austria before we prepared everything for the Eastern region. And since they didn't want to see that, we didn't include it. And I don't actually have a copy of it, so I couldn't bring it to show you, unfortunately. But the concept was we could also later bring in a screening car if you got to the stage where we felt that the ballast return would be reasonable and it would be useful to screen it on site and bring ballast directly back in. There would certainly be nothing stopping you getting back to a depot with the spoiled ballast and putting it through a screener inside the depot and putting the screen ballast that's suitable for return back into the MFSs for the following night shifts. And there again, you get the concept of saying, if you're going to do a campaign, you could then base yourself out of a particular depot. You're not working from too far away. You can manage to screen last night's stone ready for the next night. And so you go. Obviously, if you're moving around the country, that's a little bit more difficult to manage. It's moved up on the screen behind me, but not yet online. Or at least as far as I can see.
No, it doesn't seem to be moved.
Try jumping back again and seeing if that triggers it to go. Let's jump back. Okay. Yes, that's switched for online as well. Right. Next stage you come along to is the section that does the actual cutting underneath the forefoot, underneath the main section of the switch, very similar to what you'd already seen, and also with a in this case, I don't see the conveyor for drawing up the spoil stone that comes out from behind the sword. I say this was based off of the first generation one, which is how it was formed originally. We would do a new one that involved that second shoulder cleaner or shoulder element dealing with the ballast that comes out from the sword, but it does still show the ballast insertion. And the concept we had was an integrated DTS unit at the time, so that you could insert your first layer of ballast and then immediately stabilize. There's been a lot of work over the last years to set standards for how you do stabilization in switches and crossings. I think Network Rail now has formal standards for being able to do stabilizing in crossings. I'm not sure yet how much do your machines, Michael, get a lot of use using the stabilizers in the crossings. I think there's at least a standard change. There perhaps still needs to be a cultural change to make it available to use more often. What you noticed for the second generation of the Austrian machine was that instead of the stabilizing unit in there, they had utilized that section for a second clamp. Moved the second clamp slightly in front of obviously the ballast insertion, but that allowed you to be able to hold the crossing much more in a much more stable and managed way. Key to this was being able to fit all of this inside the W6A gauge, and that concept was actually designed to fit inside the W6A gauge. And I've got no doubt, based on that, we were able to do this, that if it came to it, we could certainly fit the same system as we've seen on the generation 2 of the Austrian machine, but it would need obviously reworking to fit into our gauge. Switched over. Here you get to the ballast distribution side, the new ballast receiving and delivery units. Sorry, I see there's been a question came through in the chat. Is the machine equipped with a tamping unit necessary to use tamping for DTS? No, the idea certainly of this one wasn't to integrate a tamping unit into it. It was already quite long enough without adding that, as well as the DTSing. In fact, on the high output system 5 ballast cleaner, we do have a half of a standard DTS unit as the very first element before we then do the tamping. So you run in the first layer of stone, the DTS stabilizes that layer of stone, everything's down. Then we tamp, then we insert more stone, then we stabilize again, and then you bring the support plan behind. But in this concept, we didn't integrate the tamper. We came straight to bringing the stone in, and then we imagined afterwards having the support plan come in behind it. Again, this concept was drawn up in 2013, so it was before we integrated the high output system 5, but it was after system 4, which had the first version of the integrated tamper, the 09CM, as part of the ballast cleaning, plain line ballast cleaning system. Yeah, particularly in this one, I'm not going to jump backwards and forwards too much. If you can peer very closely at the little picture at the top of it, you'll notice that there's no conveyors going over the top of the front and heading towards spoil MFSs at the front. So our concept for this one, we'll come back to later, was how we're going to manage spoil and new stone inside the MFSs, and we were going to spoil to the back and bring stone from the back as well. So all the conveyors would manage to move everything to the back of the machine. Whereas obviously the Austrian one that you saw separated in the very more traditional way, spoil to the front, new ballast coming from behind. So here you see both the spoil delivery conveyor running along the very top and a new ballast conveyor coming in from underneath to bring new ballast in directly behind where you need it. How am I doing? I'm still reasonable for time, I think. Still good. So here we come to what we'd looked at for a higher efficiency MFS concept. This was also a concept born out of some thinking we'd done for the high output ballast cleaning system, ended up not being used. But there had been some discussion, particularly at the time, We know that the high output ballast cleaning system, as far as I know, is still the longest permitted train in the UK, and still the limiting factor on how much you could do in a night is not actually the performance of the cleaner itself, but it's the logistics of how much stone you can manage to bring and how much you can take away. So we developed a concept that might be possible if it was necessary to extend that, where if you had the neighboring line available, and you came up with these multiple MFS wagons that could handle both new and spoil stone, that we could run stone out from the new wagons sitting on the neighboring track across into a hopper basically behind the cleaner and bring in the new stone. And as we emptied the new stone from these, we could then feed in the spoiled stone from the front. And we decided that it would make sense for this particular concept to do something similar. Obviously, going through a switch and crossing with this kind of machine, you're dealing with the much lower forward performance than you'd be talking about with a huge high output ballast cleaner. You're talking about a more limited volume of ballast, because you're only talking about cutting the crossing itself. And therefore it would make sense. What you do lose with these is obviously some of the container space. And I said already, I'm sure, I think at the end there may be another picture of the original Austrian one, but I might go back to it, where you see some of the MFS units that were behind that. Those are MFS 120s, and I was saying the UK ones are, I don't know, somewhere between 35 and 40. So to reduce it even further does lose you some of that space, but you recover it ultimately by being able to use the same wagons to carry new stone as well as the spoil. So in the current operation of the higher ballast cleaning systems in the UK, you have a rake of MFS at the back with new stone and an empty set at the front that's going to take the spoil. That's how you go out from the depot to your work site. And at the end of the night, in theory, you've moved the spoil into the front wagons, and you have an empty set of wagons at the back that have delivered their new stone into the work site. And that means for each trip, you're carrying a set of empty MFSs. The concept behind this was that you wouldn't be carrying empty MFSs. They'd start the night up fully loaded with new stone, and they'd finish the night fully loaded with spoil. So that each individual one carries less, but overall you could actually achieve more. So that's the conceptual drawing, but you definitely do lose carrying capacity. So to the comment that was made earlier, then our concept behind would be to use high output tamping machines and ballast regulator as the follow-up machines, very similar to what you have following the high output ballast cleaner now. For HS1, of course, they would carry on using the 0932 and the big BDS system that Michael showed some pictures of earlier. If we're looking at the rest of the UK network, obviously those will never fit. So here we're talking about the standard UK top-end tamping machines. It is possible to create a UK version of the two-sleeper dynamic switch and crossing tamping machine, but that is a very, very enormous beast. Would need very specific application to make it worth developing and delivering. But I think certainly for the timings we're talking about at the moment, we could run with some of the current fleets of 09 4x4 switch and crossing tapping machines with integrated stabilizers in them. I think these machines are relatively well known. I'm more than happy to keep talking about all of them, but these are not necessarily something specifically new to anybody. So if there's questions people have afterwards, or as you said, it will go up and anybody could later on come back and dig into the detail. It's a little bit small on the screen in front of me, and I left my glasses in my bag over there. But I think you can reasonably read it on the screen behind, or peer at it a bit more closely if it can take up a full screen. All the features of the modern 09 4x4s. There are correct me, Richard, 10, are there 12 in the country at the moment of these? Something like that. As a follow-up machine, then for the regulator, here is the not quite same as the BDS, but UK version. As Mike pointed out, this one has double brushes. It has a reasonably large silo for carrying stone that you've picked up and you need to move around inside the work site and drop it off into areas where you just don't have enough. And particularly then working through the S&C, being able to have the two different brushes for picking up the stone. This particular unit is currently owned by Network Rail. It was part of the follow-up to support plant for the System 5 ballast cleaner, and was part of where System 5 was designed to be able to also operate in third rail sections. So this was part of the reason in this case for this machine of having the two brush system. Let's jump back again. That seemed to, yes. Right, yes, right. Okay, roughly how would you use this? I say quite helpful to have seen the video because it does a much better explanation than I could ever possibly do talking in front of you. But to give a quick run through, the way we would see it is exactly in a two-shift system and do each side. The blue and the yellow are exactly the same. Michael did point out to me this might be ambitious to do it in a 5-hour shift. That may be asking a little bit much. And when you look at the sizes of what we were actually talking about here, as you get onto the later screen, we've done a bit of a Gantt chart. We're talking about a very small switch in this situation. If you go back to some of the ones that they were cleaning in Austria, we're talking about 1,200 meters switches, and here we talked about 150 meters. So yeah, obviously things need to scale up if you if you're going to be cleaning a big high output to the high performance switch, you're going to have completely different timings. But this was based off of the principally, could you cut, I'd say, 150 meters in an hour, and with all the associated setup and managing and doing it in 2 halves, so that you come in from one side and then you come in from the other side to do the opposite end. Yeah, I won't go through it in detail. The main bit that you would find, I'm not sure if you can read it. It was definitely readable on my screen when I had it filling the whole screen. There's a lot of setup work involved, and all the preparation work is over there. And then this point here, this bar is for the actual cutting, and already once that was the cutting in, getting the first part of the shoulder cut, getting the sword in place, and then this was the section where it then starts to cut in underneath and runs all the way through. And as part of that, then on the work side, we imagine bringing the tamper in already and working very closely behind it, so that you're running, obviously not in parallel, in series behind, but certainly in terms of time for managing that. And then the tamper catches up right at the end, and then you pack them away. Probably in slightly idealistic time frame to see it managed, and obviously it would depend in every work site. It also depends definitely on how many obstacles you've got, what points motors you need to get around, whether you've decided to disconnect and move them, or whether you're trying to actually cut around them, whether you're in constrained spaces, or nothing is ever the idealized. But so the stage we were building this as a potential, it was just to say what could you possibly do? Could it be feasible to fit into the operations? I say this was done for Eastern Region, and in the end they never went forward with it, but I think the principle still remains. And this was just our quick layout of how the process would work, very similar then to what you saw on the Austrian machine. The trenching was the first stage, building that space where you could lay the sword out along the side, then the sword cutting itself in, then you cut through till you get to the end. Obviously, your trench needs to go long enough past the end of it that you can bring the sword back out. And ending on. Right, that was my run through of both the Austrian one. Sorry, I had thought I had left a picture in at the back of the original Austrian one, but I'll go back to it because I think it quite helps to see it. There we go. Yeah, perhaps that one doesn't quite show the scale, but you realize what a 4.5 meter high machine looks like when you see the people stood up next to it. It is really quite an enormous beast. And cutting that down, trying to make it fit into standard UK for us freight W6A freight gauge, certainly poses its challenges, let's put it that way. But we managed to come up with a concept that could work if it was interesting and useful, and fits in with everything. And I say that was based on the first generation. I'm absolutely certain we could come up with one based on this generation, which would be a bit more efficient. Maybe that could then take out some of the idealistic timings that I'd had in, and we could get to something a bit closer. But yeah, that's the machine they went to see. This would be a proposal for HS1, and if it became interesting for the rest of the UK network, we could also do a similar sort of thing. It is, of course, we call it universal ballast cleaner in our sort of nomenclature that we often use, similar to the universal tamping machines. It perfectly well could be used to cut plain line just as well as the S&C, but obviously you're getting a much reduced rate in comparison to what you would get if you were using a plain line ballast cleaner. But it would have some benefits being used that way. Again, in areas where you have a lot of obstacles in the plain line where you're not managing to fit some of the bigger cleaners. So there also could be possibilities to get more utilization out of it if you don't have an endless supply of crossings and possessions available to clean underneath those crossings. It's not that you could, it's only useful for switches and crossings. Yeah, I'll leave it with that picture because I think that sums it up quite nicely. Hope it's been interesting for all of you to see what is possible. Obviously, perfectly possible to do it in other ways, but this is our concept for doing it in line, in this case on a single track, or in others where you've got the neighboring tracks where you want to be able to have traffic passing, or whether you want the shorter possessions where you don't want to be disturbing the crossing itself. You want to leave it absolutely in place as supported as far as possible. Thank you very much.
Thank you very much. Apologies for the introduction at the beginning. I badly briefed. I wasn't aware. All the paperwork I had with Richard, so my apologies for that.
No
it came as a complete surprise. So sorry about that.
No problem at all.
Are there any questions that we would like? Okay, fire away.
The machine you're seeing there, can it cut the ballast shoulder from the left-hand side or the right-hand side?
It can, yes.
And what about deploying the cut it underneath?
Both sides.
That's both sides as well?
Yeah.
Okay, I was just worried if you, when you came in to start the wrong way around, you couldn't do it.
You'd be really stuck. No. I think in the video, I don't know if the final version on the website will end up having the video, but if you go back into the video, I think you can see how the mechanism that holds the sword when it's in transit position is raised up, or it gets lowered down. When it's in the raised position, you can swing it to either side. So it swings underneath the machine and then comes down on the opposite side. And the same thing, you can deploy the shoulder troughs one side or both sides if you had them, and lock them up the other side. So if you've got a neighbouring line or a particular narrow area, then you bring the shoulder into the transport position and you only work from the one side.
Of the control systems with for the machine, thinking about the sort of things that are on the high output bus thing and so on at the moment. On the sword,
yeah.
For a start, as far as the longitudinal level is concerned, so there'll be a preset level which it is going to follow by the program inserted into the machine and so on. So it'll follow that through.
Yeah.
What about things like crossform and so on? Can it do that in the same way as you can with a cutter bar in itself?
Yes, you can. I don't know if I have a good enough picture anywhere inside here. I'm just going to go back and see if I can find one where we can see the unit that was close, but that's not even that's not perfect where you can see it. No, I don't have any really great. I have some photographs where you can see it a little bit better. That's probably the closest. So here you can see, I hope everybody can see with the pointers pointing, perhaps those on the screen may not, but there you can see the sword coming in underneath. This is the unit that drives the chain round the sword, but also holds the sword in the center. And this is on an arm that brings it up and down. And that's the whole thing is articulated. So you can set the sword at the angle that you want to cut for the crossfall that you want, and down to the level that you want to be cutting out at. Yes.
So if it was a crossover road, say on a standard interval on our normal route, not HS1, but on normal railway, the usual thing would be to slope towards the Cessna on either side. So you do one line first.
Yes.
Yeah. So you can actually control it in that same way as it. So you'll be doing the same thing as taking the track out and then digging it down to the level and so on. So the cutter chain can actually do that.
That's right. And that was one of the recommendations from the Network Rail team that came out earlier. The original sword, I think, was 7 meters long, and what they did was try to fix at both ends to try and get that straight. And the concept from their side was, no, look, make that sword much shorter. You can then create and keep that rigidity, but still manage everything. So that was why we ended up with the short sword at the end of it.
Just carrying on with the bit of conventional railway, if you like. If you're going underneath a lot of the SMCs at the moment, you've got to find that seriously compacted ballast underneath.
Yes.
And it will not be to the depth that you require it to be. So you're going to be cutting into almost virgin ground underneath. It's going to have a real struggle to get through the thing, you know. I'm just thinking about that's a lot of spoil to come out, a lot of new ballast to come back in, and in the same way with a plain line high output cleaner, it's not altogether it is dependent upon the return that you're going to get out of the ballast. Which will determine the length of job that you're going to
that you can achieve. Yes, that's absolutely right. I'd say when we talked about this for the Eastern region, their thinking was that the ballast was going to be in such a state that the return was going to be very, very poor. And that was why we talked about not even putting a screening car in, just coming with new stone. And that was why we talked about this potential concept of the MFSs that you came fully loaded with new stone, and you went away fully loaded with spoil at the end of it all, because you might need for this so much. Relative to the high output, I'm not sure you need 40, but yes, you would still need a big chunk of stone for each switch that you were doing. And the hope was then in the future, when you'd been through the switches and you were coming back around in the 10 years time or whatever it was, then you would buy in the screening card, because at that point then you would have stone to the right depth that needs cleaning, but hasn't been so long that it's been cleaned that you weren't going to get a good return, and then it would make sense to clean it and bring it directly in.
So
if you'll indulge me, in the history that I can fill in for you, might find it interesting, a little bit about S&C ballast cleaning in the 1990s in the UK, and then a point about the rest of Europe. So I was responsible for setting up the maintenance of HS1. And so, which is crazy given that how long ago it was, because we started 2 years before it came to be. So how were we going to do the first lot of tamping? And in those days, we were a few years in to having Unimats. I worked for Carillion, and we had I think we had 5 or 6 of them. And so we put 2 to work. And then we realised that they're just not man enough for the heavy weight of the rail and the bearers that exist on high speed 1. They're a much heavier design. So we went overseas and we eventually used the biggest Matisa machines, one at a time. And I went out to see this French crew working. And it was like nothing I'd seen. These guys just flew through it. But of course, you yeah, I think it was a U50 or something, massive machine. And then, so I'm interested that you've got to the idea of using your bigger latest generation. For those who never worked on HS1, the amount of space you've got is just a dream. But the problem we found is the track was built so good that, and we were measuring the track geometry every month. Every time we went in the early days, all we were doing was pushing one track fault to another, because you can't see the faults with the naked eye. And we were just making a mess. And any thoughts of ballast cleaning had gone away. There's going to be no problem with depth, Malcolm, because you climbing up the ballast shoulder on HS1, it's almost a metre.
Yes, on HS1, fine.
Yes.
Anyway, so laughing apart then, so I was a track maintenance engineer from London to Reading, or almost to Reading. And back in the day, in the summer of 1989, we had to go with an S&C ballast cleaning, which was an RM74 with an extended cover band, and probably Rottney was on crew that weekend. And it did this lead in the down main at Maidenhead East. And the problem was you couldn't control the far end. And so it dug a swimming pool. It was filled with stone, which probably collapsed on the Monday afternoon. But of course, the maintenance guys were in there trying to lift it up. But subsequently, I had to go further north on the West Coast main line in Lancashire and Cumbria, because I think it's the same principle what Network Rail have found, that the plain line was definitely a ballast clean and rail changing thing, no sleeper changing. The S&C was all Jarrah, and trying to get proficient at gigging a crossover, and they were probably nowhere near the size of the ones in Austria. We eventually got to doing it reasonably efficiently, but in parallel, we're using PEM to lift the whole track out, and we got more efficient at that. And because the pen lens come on the back of the lorry and not in transit, the logistics got easier. But anyway, enough of my chapter in my memoirs about S&C ballast cleaning and HS1. S&C ballast. Oh yeah, I saw S&C ballast cleaning or ballast cleaning done in Japan using a cutter in 1998. So I don't know. It's probably one of your machines, plastic machines. But in Japan, they only have 6 hours. Everything has to be done in 6 hours.
Yeah.
And so it costs the earth. And yeah, it's little Japanese guy with a small hats on, standing on the cut bar as it was going.
There are some amazing things developed for Japan, but their methods of work wouldn't be easily importable to here.
They're brilliant railway engineers and constructors and maintainers. Anyway, so great opportunity, anyone goes out there. But the high-speed networks in Europe are, of course, that much older than ours. I mean, the first bit of the Paris-Lyon was 20 years in advance of our HS1. And by the time we'd opened ours, they'd had to ballast clean the whole lot. But what do they do in the rest of Europe with S&C ballast cleaning?
Well, it's a mixture of the different things at the moment. So this was a concept that was developed as a way of trying to do it as an inline without taking the crossing out. And you've got the two options. Ultimately, you go with put all the extension pieces in a plain line ballast cleaner and come through, or you take the crossing out and do it, but then what you end up doing is disturbing the crossing. And so what we're looking at here was how do we move forward in the same way we've brought in line ballast cleaning to plain line ballast cleaning. How do you do it without taking the crossing out, without disturbing it, with the minimum impact? If you go back to the Japanese example, we did a sleeper changing unit for them. And for the Japanese, what was absolutely critical is that you disturb as little as possible with each element of what you do, so that if something goes wrong, 6 hours is utterly protected, because the most important thing to them is that on the minute that it's due to open, it opens precisely. Probably minute is not even, that would be a complete waste. It's got to be to the second in Japan. When it's due to open, it must open. And so as you said, they were prepared to develop very complex, quite costly systems to do the absolute minimum, each individual element of what it did.
50
Yeah.
The guarantee.
The guarantee
And
that,
of course, they
yeah.
cut 50 metres in about half an hour.
But everything else around it is protection. Yes, yeah, that's it. And so this is to fit into that zone where how do you clean without disturbing the crossing, with doing perhaps not quite as minimum as you might be talking about in Japan, but doing the least amount to it while still achieving the end result, and potentially keeping the neighbouring lines open if you can do that. All of that leads to improvements in the long term. But this is say second version of this second generation of this particular cleaner, but this is the only one so far created out
So what
there.
do they do then?
Instead of just
Supposed to take the whole things out on a
Yeah.
the Cersus system and
yeah.
take it all out and put a unit back in an 8-9 hour possession.
Yeah.
You know, working in Germany in the early 2000s, we did ballast cleaning, plain line, and renewal. Yeah, no problem. But for S&C, they basically dug down, including formation, 1.5 meters below rail level, and then build it all back up, and then fingers crossed it lasts for 30 years. that machine wasn't available.
Wasn't, yeah. And I think that's what you've been finding with HS1 now. So in the beginning, it didn't need cleaning, but you're reaching the point now where the tamping campaign is showing you every year the same pieces being touched because it's not holding anymore. So you're reaching the stage now where the ballast in some areas has reached the end of its usefulness as it currently is and needs to be cleaned.
Well,
by pure serendipity, I actually was at a talk on Monday from John Edgley, the Yellow Rail track engineer, where he was trying to defend the standing down of the high output ballast cleaners by saying it was the way that Network Rail used them that was costing them the large sums of money, and they just weren't cost effective. But he did say that you got more bang for your buck, or buck for your bang, whatever way, by doing S&C ballast cleaning. So I was fully imagining that I was going to come here today and you were going to tell us what.
So you're an HOVCS5 doing.
Going to be the Network Rail machine. Have they shown any interest at all?
I don't think they've ever cleaned a crossing or switch with the high output ballast cleaners. No, but I would say, looking at what we've seen over the last years and compared to the times when they were at their most efficient, one of the things we notice is that they do a lot more, or have been in the recent past, a lot more of these very short bits, and then pick up the circus and move it somewhere else. And you end up looking at the traveled miles of the cleaner as it's hauled around the network compared to the time cutting and actually doing its job. And it's inevitable that it's going to be less cost effective than if you go up night after night after night. And of course, what you also get is if you've got a stretch to do, and I would argue that if you've got a stretch and in the middle of it, you've got some bits that need cutting now and some bits that need cutting next year and some that might need cutting in 2 years' time. If you do the entire stretch this year, some of it you'll have done a year or two earlier. But what you won't get is a clean bit and an old bit and a clean bit and an old bit. What you will get also is that if the first night you don't quite achieve what you needed to, it doesn't matter because you're going to go out the next night or the next week and carry on and carry on. So you will get through, and the crew gets to know, the machine gets to work every night. They get to know the area. They get to know the setup. You're not traveling too far from work to and from. The logistics is manageable. You can get the stone in and out. You're not wasting a lot of time traveling around the network, so you can spend more time actually maintaining the machines, so you keep them up at a higher reliability. That there is a lot that feeds into managing it in campaigns, and I think that slightly got lost, and it partly got lost in the well, we only want to do this little bit because that's the bit that needs cleaning this year, and then we'll go somewhere else, and then we'll come back in 6 months' time and do a bit that's only 100 meters further down from where we did the previous lot. That's not an efficient way to do it. But it needs a whole integrated round the network approach to that. And it needs people to say, yes, this individual section only needs cleaning in 2 years' time, and this section only next year. But all of these pieces around it need to be done now. So we just do the whole stretch in one go and realize the future savings now.
Rodney, you can.
I've been struggling to remember, and I think there's only Malcolm here
might remember better than me, when we first used ballast spinners on the Great Western Main Line, I guess it was in the 1970s.
No, ballast spinning was done earlier than that. I mean, we had the repeater machines before the Sasser ones back in the late 50s. Which we were using then, but it wasn't a common thing to do. But ballasting was done at that time. The plaster one started in the 70s.
So that's my earliest memories of ballast spinning. The more interesting thing for the general population here is that we on the Western Philip Reese's railway used to ballast spin to a depth of sometimes 18 inches. Until, I suppose it was the business-led decision that we can economise only ballast spinning 12 inches depth. Well, you've heard how providing a metre of ballast underneath the track made it last a hell of a lot longer. But one of the lessons we learned was that ballast spinners produce a canal. Basically, the ballast didn't get cleaned far enough to reach the drainage even. So if you look anything like a clay subsoil, the water wasn't actually getting away from underneath the track. I think that sword, what you've got there, is the most beneficial implementation that I can think of. What I have also remembered is your ballast now is coming out of a machine. We used to have to run dogfish or ballast wagons with tubes, and running alongside a ballast wagon, unloading the ballast was shall we say, an interesting exercise. You had to be fit, and you had to make sure that the gang were not fit. But we actually relied on the engine driver's skill to run the ballast wagons at a continuous, gentle speed, because if they came to a dead stand, you've got a pile of ballast.
Yes.
Which was
Knocking the plough down at the right place as well.
but we didn't have any sharks in those days, if I remember. One or two sharks on the patch. So that machine, or this design of having these chutes, has got two particular targets, I think. And I'd like to be out on one of those machines, but I wouldn't be allowed in.
Yeah, they are quite amazing to see, and certainly if you look at the plain line System 5 ballast cleaner with the aim, I don't know exactly what depths they do cut to now, but one of the aims that we tried to introduce with System 4 and then particularly System 5 was that also when you lay the ballast in, you put it in layers and consolidate each of those layers. Because one of the concerns was if you just fill a huge pile up with the ballast, you end up over time consolidating the top layer and the bottom layers aren't well consolidated, and then everything starts to move later on. Whereas the concept with the System 5 was to bring the stone in layers and consolidate each of those layers individually so that you've got a really consolidated bed of whatever you have to stir and then put in.
In other ways, the track, when all is said and done, it still has to be lifted by tamping. How much?
I
No.
Yeah, I didn't have figures for this, but we did look around and we were talking, we think about 70 mil at them.
They've only got 5 metres unsupported.
Yeah.
So they're going to sag very much.
Yeah.
And they're putting it back straight away.
As quick as
So
possible.
It's a dream.
Yeah.
I'd like to go and have a look too.
Yeah. Especially in this example, because when we're talking about only cutting half out, the other half is still sitting on where it was originally. So you can't leave it any lower because your switch can't bend around that. You do have to keep it exactly where it was, because otherwise the whole system isn't going to end up working very well. So, yeah.
Start take to run it on site, and what sort of ballpark figure are we talking of if you wanted to buy a set?
8 operators that yeah, but I couldn't give you a price right now for, like I say, the last time I looked at it was 2013, and the world has changed so much since then. I would hesitate to even think about estimating it. We'd have to look at it new, and I said what we'd probably want to do is redraw the concept for Network Rail track to take account of the improvements we've made to the Euro 700 to make it the generation 2, because I think they were good improvements that were made to it.
Richard, you had a question.
Well,
Richard.
okay. Well, I'm for this sophisticated discussion and based on experience. Mine's very simple. Or a couple of doing single line cleaning. Would there be a scoop picking ballast up? Do you cut both sides of the sleepers and then go completely underneath so one can actually look through and see your colleagues not doing anything on the other side? Okay.
Exactly. So depending on what obstacles you might find, you would go along. You could then go round.
But the idea
yes,
would be to take both shoulders out and then.
There's no reason you can't be
leaving
using
one
both
in
shoulders.
so
Yes.
annoyance on the other side. And the other little detail on the double-sided one, that really good diagram with the blue and the grey, or blue and the pink. Would the cutter actually go exactly 50%, or would you tend to go under the other area by an amount so that you didn't end up with a strip in the middle that was never touched? You know?
Yeah.
Overcut both ways.
You would overlap so that at the end you cut out some of, when you come to round 2, you will have cut out some of the stone that you just recently laid back in. Yes, you exactly don't want
over the
yeah.
stone maybe.
Yeah.
Yes, okay. That's very simple points, but just to understand it.
But that was the aim of, I can't remember the exact length of the sword, but we're talking about a 4-point-something meter sword, and the idea was calculated out to get the shortest length of sword, but that you can still reasonably cover everything you need to do.
2.6 meter arms, that gives you plenty of width in the set
And
some extra, and not have to go up 9 degrees as well. Because if you tilt it a bit, your cutter's not working quite so hard.
Yeah.
So, Malcolm, did you have a point? Or?
Yes, I just back onto the control systems again, and following on what Rodney was saying. I mean, my principle has always been, tamping machines are okay, they can lift, but they're not lifting machines. That's not what they're there for. As far as the URMs are concerned, say on the continent, is the finish behind that particular machine, is that to leave the track perhaps, let's say, 30 millimeters above design level, and then have the DTS run immediately behind it, then leaving the tamping machine to do what its proper job is, to make a proper longitudinal level and cross level on it.
I would probably first pass that to Michael. What did you actually see when you saw them do it? Do you remember what the end result was?
60-70 mil lower by that machine. Yeah. We didn't see the tamping machine in action.
What actually happened?
Operator said they had at least 2 tamping passes, so possibly like a 40 mil lift and then a 25 and.
Yeah.
Oh, I don't think the DTS is on it, is it?
No, this doesn't have a DTS integrated, so the DTS is only on the tamper. It's only on the tampers, yes. Yeah.
And the final run is always the DTS.
Yeah. It's especially because, and you even see it in that picture there, because they've got the overhead wires, they control the heights very carefully with everything they do.
Yeah.
Like, so when they do tamping, it's nearly always design tamping, and it's always to bring the level back to the original, the height back to the original height.
Design agreed with the overhead line.
Overhead line to, yeah.
Okay. I think pretty much we haven't had many questions from home. Are they still alive? Anything from the online end? Oh, you're still on mute, right?
Yeah, not for me, thanks.
Okay.
Can I make one further comment if it's okay?
Okay. Yeah.
I had I was able to go and see the machine, the formation rehabilitation machine that Swidowski and OBB and Placer had done a fair few years ago, which now trundles its way around various countries, I think.
Yeah.
It was quite a unique piece of kit actually at the time. I mean, the amount of material that actually takes out, puts back again, and the range work that it does as well. It's quite remarkable. When you first look at this S&C ballast cleaner, it looks a very complex machine. Well, yes, it is, but I think, that would then make me think, there's an awful lot that can go wrong on that during the course of a shift, and one thing going wrong stops the whole process as well. The thing is that formation rehabilitation machine it's more complicated and more complex than this is, but in fact, as far as I understand, it's been very reliable.
Yeah.
So there's something for this, and most of the technology that's in it is not new technology. It's just joined it all together.
It's just putting it together in a
put it all together.
specialised way, and that's
So yeah, there's a lot going for it, and it's certainly something that we should have, or we should have had years back, quite honestly.
yeah. I did very, very long ago, although I don't know if I could find it now, get a UK concept drawn up for a formation rehabilitation machine, but the logistics of the material handling, that would be absolutely enormous, because there you would need to manage a more European way of handling the stone, because there's just too much volume of material taken out and brought back. Even if you do what you said, that the very higher layers that are going to be spoiled get crushed up and put in down at the lower layers to do as much recycling as possible, you end up with such an enormous logistic. The continental way of managing the stone is to have a smaller number of MFSs and shuttle them backwards and forwards, where we try to just deal with everything in one. If you went to that sort of thing, you actually will have to manage it like that, because you just wouldn't be able to carry enough material with you for a shift.
The final comment really is you were mentioning about campaigns and strategies. So in other words, whatever the machine can do in the time given, that's what you do. It doesn't really matter if it's 3 or 4 years down the line before you need to do it. But there's the rub, you see, as far as we're concerned. Michael will say this sort of thing. The number of times that the high output equipment has been taken out and just does what it has to do, and yet in actual fact you've taken out a piece of kit that could do 600 meters that night, but it was only programmed to do 420. So it went back early and everything was all very fine, but you might as well have done the 600. It only cost you the material. It wouldn't have cost you anything
like all the rest of it is there. The deployment is a huge element.
That strategy isn't there, is it, Michael?
Unfortunately. Yeah.
Okay, well, Michael, thank you very much. We could probably go on lots more questions for hours, but we have to call it a day at some point. So, Richard, could I ask you to do the vote of thanks, please?
Yes, you can. This is a pre-arrangement in that if we haven't fixed who's going to do the vote of thanks, I end up with a job. But this is a great job to do. One of the things that I think PWI meetings are noted for, certainly they should be like this, I think, is looking at a subject in detail, a very simple subject, so that one can understand it better if one's not an expert in that particular area of that particular subject, so that people who are watching online or will look at the now videos and so on afterwards can pick up detail and really understand a particular aspect of the whole job of railway work. I think our meeting tonight has been another good example, and thank you very much for coming on. Incidentally, the confusion over Mark and Richard is entirely my fault, but I blame cut and paste or the email system or something like that, because your name did feature in the paperwork at one stage, and then it got to change. But anyway, you're both here, so the ploy actually worked, because you've both come rather than just one of you. But anyway, going back to the talk, the thing that struck me, I'm probably least qualified to talk about ballast machines and ballast work and all that in this room, but something that struck me is that I now understand very much better how a complete train, the complete units working from, starting to the right through, it works, what the concept is, the issues, some of the issues. We did have a visit to the Taunton high output cleaning depot a few years ago as a section, and had a really good look at machines there, and they understood a lot of the issues there. So this all fits together with other experiences. So it was a really good, simple explanation, I thought, to people who probably know all about it, but we always learn something new from looking at what we think we're familiar with. The other thing, I hope that obviously it was lovely for those of us in the PWI to be looking at bits of ballast. I know this is what we love doing, but I hope if you came along as a mechanical engineering member, you were equally enjoyed looking at the machines themselves. Although Malcolm's just made the point that maybe they're not that complicated, but as we say, one thing going wrong and that's that. Well, they are complex, aren't they? But to consider as one listened to the talk, the number of different pieces of equipment and what they all had to do, and just thinking of the number of men with ballast forks all that lot has been able to replace. I think it's just wonderful. So an excellent talk. Thank you. We wouldn't expect anything less from Plassers and Swieselski, but we've enjoyed it very much. We hope you enjoyed the environment. This is a bit like a work site, isn't it? We used to work sites rather than the finished thing for the people from the offices to come and look at. And we look forward to next year's meeting, where we'll have something really good about mechanicals and the track work pole infrastructure as well. And wish you well on your way home. And as you travel home, if you're going on the train, just think of how good the ride is and whether Swieselski and Plassers have been through there lately. So thank you, everyone. And I suppose we ought to do this all.
Hey, thank you very much. What have we got? Richard, next meeting for the PWI, please.
Yes. Well, it was going to be about something to do with subject. It doesn't really matter. But what's happened now, I hope we haven't upset you, is that the talk is going to be about ballastless track systems. But of course, we all know that ballast is much better. But anyway, Peter Barber is coming along to talk about that. And you'll get a full write-up about it in the news lines that follows that meeting. So that's our next actual PWI Thames Valley section event. I ought to let slip, really. I want to, in that we were planning to go to visit Plassers on the 20th of March 2020. On the 15th of March 2020, Mr. Johnson said we've all got to stay at home. So we've never made it. But I gather by in corridor talks this evening that there may be a prospect of a visit perhaps a bit later this year to see something really interesting. And obviously you will get details of that in due course. I think the other function of sections, of course, is to try and fix visits to things. As you said, it's difficult to go out on site nowadays because of dust and all the other issues to do with being there when you shouldn't really be. But at least we can go to depots and look at machines and understand where things are going. We did have a loop of pictures to use tonight of our visit to the Chiltern Railway depot at Wembley, but the technology wasn't. It's probably my fault for getting it all ready. So, but anyway. Depot visits at least keep us going as a section of professionals. So that's those are the notices I can think of. Thanks,
Well,
Chair.
the idea was you're going to tell us the 5th of February. Did you actually say that?
Well, no, I didn't, but it's written down here, you see.
Okay, 5th of February, next meeting, just in case. Mick, do you want to say anything to your guys?
Just a quickie. Our next meeting is the 10th of February. That's in Swindon at Western House. It's our annual Future Rail presentation competition. So it's young engineers giving their 15-minute talk. And it's a competition, and it's a real good fun evening. Really recommend anybody who's available. So that's the 10th of February, 5 o'clock at Swindon. And talking of visits, we still have aspirations to go to West Ealing, but to go to the battery train. at West Ealing Station, and see that, and have the Great Western Engineers explain the process to us. Which, as I said, that's an aspiration. It's likely to happen in the early part of the year. I can only ask you to keep your eyes on the website, please, and I will advertise it there. Thank you.
Okay, well, thank you very much. Thank you for those at home. There was a couple of questions. Loads of people said thank you very much. So just you can come and have a look at those afterwards. There was one chap said, brilliant presentation. Are the slides able to be shared? Well, they should be on the PWI website at some point. Once it all gets written up and sorted out. So I don't know if that was one of your guys asking but I think they should be able to get them off the PWI website. So hopefully that person hasn't disappeared and has got the information they're looking for. So thank you for those at home for tuning in. Thank you to everyone else for venturing out in a potential storm warning or whatever they was panicking about. It remains to be seen if we actually all get home this evening. So thank you very much. Thank you for your attention, and we shall see you next time.
Yeah, thanks very much. Bye.
Thanks, Ray. Bye.
Cheers and bye.
How many more, Max?
24.